Hello everyone, I welcome you all in this course Introduction to Sequence Stratigraphy, and in continuation to our discussion from the last class where we were discussing about the different types of sequence, we will continue that discussion over here in this class as well. In the last class we discussed about the depositional sequence. So, the other two types of sequence, the genetic stratigraphic sequence and the TR sequence or transgressive regressive sequence, these two we will discuss now in this particular class. So, let us start with the genetic stratigraphic sequence. So, in genetic stratigraphic sequence, we commonly use the maximum flooding surface as the sequence boundary. This already we have seen in the last class, in the previous class, where we have tried to understand that what could be the arrangement of different system strats or packages of strata in between these surfaces when we are defining these different types of sequences. So, there we have already seen that a genetic stratigraphic sequence will start with maximum flooding surface at the bottom, then we will have arrangements of the different system strats, and finally, it will end up with the next maximum flooding surface. So, it can be identified both in the continental side as well as in the marine side. So, if I just try to draw it again just for our understanding. So, in case of a genetic stratigraphic sequence, the bottom surface it should be a MFS, that is the maximum flooding surface. So, definitely the package below this is the transgressive system strat, because we know that a transgressive system strat will end up with a maximum flooding surface. So, on this maximum flooding surface what we get is a first an aggradational plus progradational package which we call as the HST package, which ends up with a BSFR surface. On this BSFR surface or on this HST package we get another coarsening upward succession which is the forced regressive part or commonly called as the FSST package, the falling stage system strat. This will be overlain by a correlative conformity surface, and this will be overlain by another coarsening upward succession, another normal regressive package which we call as the LST. This LST will be marked by the maximum regressive surface, and on this maximum regressive surface we will get a fining upward package which is the TST package, which will be marked by the maximum flooding surface. So, as per definition, this package starting from one MFS to the next MFS is one genetic stratigraphic sequence. So, basically over here what we are getting in the lower part, it is the regressive package followed by a transgressive package. So, this can be identified in both in the shallow marine part as well as into the marginal marine part or into the fluvial part, because there we can identify this maximum flooding surface and these packages in entirety. However, when we are looking into the marginal marine part or maybe when we are looking into the fluvial part, this FSST part may be absent and this may be replaced by a major unconformity surface which will be lying in between this. So, when we are trying to define a genetic sequence from the marginal marine part or from the continental side, in that case again it will be one MFS to the next MFS and it will be a package of HST, TST, LST and unconformity surface. So, this is how a genetic sequence is defined. So, why MFS is considered as the stratigraphic bounding surface for a genetic stratigraphic sequence? The reason is the principal changes in the paleogeographic distribution of different depositional systems and the depot centers, they occur during times of maximum shoreline transgression. So, what is the meaning of this? This means that this maximum flooding that occurs when there is a maximum shoreline transgression across the entire basin area, and commonly it is the same time period. So, it can be or its representation will be exactly same or very much similar across the entire basin. So, identification of this maximum flooding surface will be quite easy and it will be quite correlative. So, any such changes in the distribution of the depositional systems and the depositors will mark significant shift in the sediment dispersal pattern across the maximum flooding surface. So, commonly this maximum flooding surface can be identified in the rock record as a downlap surface, because just overlying that we get the HST sequence. So, very easily it can be identified. Maximum flooding surface commonly indicate the very fine grained sediments, and above that fine grained sediment package we get a downlapping surface, a downlapping package which is progradational with aggradational in nature. So, in terms of its geometric appearance, it becomes very unique, and that uniqueness help us to identify these and correlate these across the entire basin. So, the genetic stratigraphic sequence is subdivided into several system tracts, starting with high stand system tract, low stand system tract and the transgressive system tract. So, we are basically using the same system tract terminology as we have used in our previous classes when we introduced this term of sequence elements, when we have tried to understand what are the different sequence elements and the way we have defined these different system tracts, as well as when we use this terminology in the case of depositional sequence that we discussed in the previous class. So, the concept, the idea of high stand system tract or low stand system tract or a transgressive system tract which constitutes a genetic stratigraphic sequence, that remains same as it is used in other cases. So, in this case when we are defining a sequence with respect to the maximum flooding surface, this often overcomes the problems related to the recognition of depositional sequence bounding surfaces. Say for example, we face problem in identifying the correlative conformity, as we have seen in the previous class during the discussion on depositional sequence. So, we can get some confusion, some problem in recognizing the correlative conformity surfaces in many cases, and in those cases defining a depositional sequence may be very difficult. That can be overcome over here when we are defining a genetic stratigraphic sequence, because here we are marking the maximum flooding surface, because maximum flooding surface is relatively easy to map across a basin because of its unique characteristic. So, this particular surface, this particular package is associated with regionally extensive fine grained sediments, very commonly the shale units. So, this maximum flooding surface are often very easily can be mapped from the well log data, from the core samples, from seismic data even, and definitely from the outcrops. So, if I compare this with respect to subaerial unconformity, it may be even more easier to recognize or identify from different sources, from different input methods, and very easily it can be correlated across the entire basin. Now, in addition to this, we can have further advantages in terms of using maximum flooding surface as the sequence boundary over here. As many geologists, they prefer to start their stratigraphic analysis with mapping MFS, because it can be very easily recognized. The basin wide extent of the maximum flooding surface means that the genetic sequence is uniquely bounded by the same surface within both continental and marine portions of the sedimentary basin. Now, definitely there are certain limitations as well. So, what are the criticisms of this particular model of defining a genetic stratigraphic sequence? So, within this genetic stratigraphic sequence, as I have explained to you in this diagram that I have just drawn over here, we have marked the unconformity within this sequence, particularly when we are defining that from the marginal marine part or from the continental side. So, in that case the FSST package will be absent and it will be replaced by a subaerial unconformity. Now, the subaerial unconformity, its presence, it will indicate that there is a break in the sedimentation. and some erosion has occurred or some bypass has occurred, and after that event of erosion or bypass, definitely there has been a change or shift in the depositional condition, which is leading to the deposition of the next unit, that is an LST unit. So, this changeover may not be exactly in the same order as we have seen below the unconformity and above that unconformity. So, in these cases the term genetically related strata may not be valid, because in this case we can get unrelated strata which are genetically not connected to each other, completely different package of strata, completely different depositional system can come over here. We can recognize them or identify them and we can put them within the same package, but we are putting them under the name genetic stratigraphic sequence, whereas they are not genetically linked because they are interrupted by some erosional process in between. So, that is the number one negative aspect of defining a genetic stratigraphic sequence. On the second point, we can think of the timing of formation of the maximum flooding surface, because ideally we can think of the maximum flooding surface, it is an unique surface forming across the basin, but actually it does not happen like that. What happens is, it is mostly dependent on how the base level change and sedimentation is going on in different parts of the basin, and what is the exact time of deposition of the finest grain size during the transgressive phase. So, when the transgression is reaching to its maximum at different parts of the basin, that can vary, because it is entirely dependent on that balance of rise of base level and sedimentation at different parts of the basin. So, maybe within a large coastal area, in one part of the coastal area we can have a very earlier setup of the transgression leading to the peak of the transgression early, whereas within the same basin but in the other part of the coastline, maybe the sedimentation rate is much higher and that is leading to little bit slower transgression, leading to little bit late peak of the transgressive phase. So, definitely the MF phase that will form in the second case will be little bit late with respect to the first case, and when in the rock record we will try to correlate them, they definitely will indicate a diachronous nature. So, when we are trying to using them, when you are trying to using them to define a sequence boundary, we are basically trying to use a diachronous surface. So, sometimes that can be a very big problem, very big issue, particularly when we are dealing with large stratigraphic successions. The genetic sequence is linked to the manifestation of shoreline regression and transgression. So, it requires evidence of syndepositional shoreline shifts in terms of transgression and regression for the proper identification of the transgressive deposits, the TST package, maximum flooding surface, the LST package, etc. Without proper identification of them, it will be very difficult to understand or demarcate a genetic sequence. So, this model may not be applied to overfilled basins or towards the upstream fluvial processes where the control factors are completely different. As we look into the genetic sequence where the subaerial unconformity is not the sequence boundary, but it is occurring within the genetic stratigraphic sequence. So, this model can be applied to marine basins characterized by continuous base level rise, because in such cases the unconformity part will be completely absent. So, in the absence of subaerial unconformities, the cyclicities which will be controlled entirely by the interplay between rising base level and the sedimentation will lead to continuous conformable succession covered by maximum flooding surfaces. So, in such cases the genetic stratigraphic sequence can be very effectively used, but in those cases where we have intermittent subaerial unconformities, we cannot use the genetic stratigraphic sequence. Now, we can move on to the next type of sequence, that is the transgressive regressive sequence or the TR sequence. This particular type of sequence was first proposed by Embry and Johansen in 1992, and they are often very popular because over here the identification of the package is very easy. So, in this particular type of sequence, as the name suggests, TR sequence, transgressive regressive sequence. So, it is a transgressive package followed by a regressive package. So, at the bottom part it is commonly represented by the maximum regressive surface on which we get the transgression, and it will be ending up with the next maximum regressive surface. But in most of the cases it is not that simple, rather it is bounded by or represented by a composite surface which includes subaerial unconformity on the basin margin part, whereas if we look into the marine portion of the basin we get the maximum regressive surface as the bounding surface. As we have seen in case of the depositional sequence where we get a composite surface, in this case also in this transgressive regressive sequence we again get that kind of composite surface because of some complexity in arrangement of the strata that we commonly observe towards the landward side. So, in case of transgressive regressive package, what is ideally what we can expect? We can start with a maximum regressive surface. So, in this maximum regressive surface below that we get the LST package. On this LST the end of the regression, and from here we get the start of the transgression, which is a fining up package. So, this is the TST package. So, definitely it will be marked by MFS. On this TST we will get the HST package, which will be marked by BSFR, basal surface of forced regression. Followed by that we will have the FSST package, which will be marked by the correlative conformity or the unconformity, and on this we will get the LST package again, which will be marked by the next maximum regressive surface. So, one transgressive regressive sequence will be defined as this package of strata starting from one maximum regressive surface to the next maximum regressive surface, where the initial part is a transgressive part up to this, and over that this entire portion is the regressive part. So, transgressive regressive package leading to the transgressive regressive sequence. The scenario becomes bit complicated when you look into the fluvial part of the basin or towards the marginal marine part of the basin, where the subaerial unconformity which is present over here, the subaerial unconformity, this may often lead to the removal of this LST package, and this MRS may get juxtaposed with this subaerial unconformity. In those cases we can define the TR sequence as the transgressive regressive package bounded by the subaerial unconformity. So, it looks very much similar as the depositional sequence. So, when we try to look into this transgressive regressive sequence model, it offers an alternative way of packaging the strata into sequences, where we try to bypass some of the pitfalls of the depositional sequence and the genetic stratigraphic sequence. How we can do that? The TR sequence model, it commonly uses the subaerial unconformity as sequence boundary, particularly when we are looking into the continental side or towards the marginal marine side, where it is exactly same as the depositional sequence. And we have seen that in the continental side, using this unconformity as the boundary is very effective over there, because it is bounding the transgressive regressive packages bounded by the unconformity surfaces. Whereas in case of depositional sequence, we face a problem in terms of defining the correlative conformity surfaces. That can be overcome over here in TR sequence model, where the boundary is placed as the maximum regressive surface. It is very easy to identify the maximum regressive surface because that marks the turnaround point from a coarsening upward to fining upward succession, end of the regression to start of the transgression. So, identifying the maximum regressive surface is quite easier with respect to identifying the correlative conformity surface. So, in such cases the sequence boundary can be identified as maximum regressive surface, and that is the advantage of using TR sequence model over the depositional sequence model. So, when this kind of condition arises, the correlative conformity surface should be avoided or should not be identified at all, and we try to identify the entire package as a regressive package. The correlative conformity surface in such cases, when you are trying to define the TR sequence model, is commonly juxtaposed with the maximum regressive surface in the marine portion. So, this stratigraphic surface is commonly recognized in the shallow water settings on both outcrop as well as in the subsurface data, and it may pose some recognition problem in the deep water setting, because in the deep water setting the depositional conditions are completely different, they are not continuous as well, and in those cases within a conformable low density turbidite phase succession, the arrangement of these surfaces or occurrences of these surfaces may be completely different. So, there we can face some problem. Apart from that, when we are looking into the shallow marine part, recognizing the maximum regressive surface in place of correlative conformity surface is very easy. A common potential problem that we can face when we are trying to recognize the maximum regressive surface is that the timing of its formation, because its formation depends on the sedimentation rate. In different parts of the basin, the end of the regression may be different because it is dependent on how much of sediments are coming into the system. So, this surface, this maximum regressive surface may record a significant diachronity along the strike of the basin, and when we are trying to use this maximum regressive surface as the bounding surface for a sequence, that may lead to some problem in terms of defining the sequence boundary. So, in this case it is exactly facing the same kind of problem that we have seen in case of genetic sequence. As the influx of terrigenous sediment to the various sediment entry points into the marine basin can change considerably along the strike, the onset of transgression may be delayed in areas of high sediment supply. In such areas, the maximum regressive surface is younger than other areas of the basin where we commonly get a lower sediment supply. So, for the non-marine portion of the basin, the identification of this maximum regressive surface is problematic, and in those cases the subaerial unconformity is commonly used as the sequence boundary, as it corresponds to the most important break in the sedimentation, and it should not be included within the sequence. In case of genetic stratigraphic sequence, we have seen that we face that particular problem of including the unconformity within the package. So, in transgressive regressive sequence, we do not include them, rather we put them as the boundary. So, maximum flooding surfaces are used to subdivide the TR sequences into transgressive and the regressive system strats. A common pitfall of the TR sequence model is commonly faced in terms of the non-marine and marine portions of the sequence boundary, because that is becoming a composite boundary. In one part of the basin it is represented by the subaerial unconformity, whereas in other part it is the maximum regressive surface. So, commonly we expect or we face a temporal offset in between the formation of these two units, because if you can refer back to that basic idea, basic concept of how these different types of surfaces are forming with respect to this changing base level curve. So, the formation of maximum regressive surface and the formation of subaerial unconformity are not exactly at the same time with respect to the base level curve. So, what we can expect when you are trying to compare them from the basinward side with the marginal marine part, there should be some temporal offset in between the duration of how much low stand normal regression is occurring in between them, because the subaerial unconformity will be followed by this low stand normal regression, the package of sediment that will form, and it will end up with the maximum regressive surface. So, the amount of low stand normal regression and the resultant package of sediment that is forming above the subaerial unconformity before the formation of the maximum regressive surface will define how much temporal offset will be there. So, what we can expect? We can expect the tear sequence model can work effectively only when the original thickness of the coastal to fluvial low stand normal regressive deposit is very low, is negligible. So, in such cases it may limit up to few meters, where the amount of that thickness of the low stand package is even less than the scouring associated with the subsequent transgression. In such cases, when this transgressive refinement process by tidal or wave processes will continue, will occur during the next transgressive phase, that low stand package will be almost eroded away, removed from the system, and the transgression will directly come over the unconformity surface. The transgressive package will directly come over the unconformity surface, and then we can correlate this unconformity with the maximum regressive surface of the basinward site. So, it may be a very restricted or very limited application, but when we look into the system separately, for example, if we are looking into the basinal part separately or we are looking into the marginal marine part separately, there we can use different models depending on our requirements. So, in case of genetic sequence, as we have seen earlier, the similar kind of problem can be observed in terms of the shoreline shift. So, in case of tear model, the problem faced with the shoreline shift, and therefore, it cannot be applied in overfilled basins or in fluvial successions, particularly the upstream controlled fluvial successions, where the accumulation of sediments is independent of the marine base level change. So, in all these three types of sequence models, what we can observe here is each of them have their own advantages and each of them have their own disadvantages. We can use the genetic stratigraphic sequence in certain cases, particularly when we have the entire package of sediments present, erosions are absent, and we can very easily identify the maximum flooding surface across the entire basin part. In such cases, defining the genetic stratigraphic sequence is very effective. Whereas, if we are trying to identify the packages in terms of transgressive and regressive cycles, then identifying them in terms of tear sequences become very easy or very effective. But again, in such cases, we have to look into one maximum regressive surface to the next maximum regressive surface, and we should overlook or we should avoid the intermittent erosional phases. If there are erosions commonly associated with the subaerial unconformities, they have to be juxtaposed with the maximum regressive surface, then only we can identify the tear sequence in the continental side or in the marginal marine side. Whereas, defining the depositional sequence is best possible from the continental side, from the marginal marine side, where the packages are defined in terms of erosional surfaces or the subaerial unconformities. So, in terms of these packages, how they are occurring in different parts of the basin, workers from years they have tried to use these different types of sequences, these different types of models, depending on how they are defining or what is the aim of their particular work. So, what is the takeaway message from these two classes? The basic concept of defining these sequence elements, they remain unchanged, they remain same. The way we define a TST, we define an HST, LST or FSST, the way we define a subaerial unconformity or a maximum flooding surface or maximum regressive surface, that remains same, and that is entirely dependent on the base level curve, the tear curve and the associated sedimentation, how the rate of base level curve is changing with respect to rate of sedimentation. Now, keeping that basic concept in our mind, looking at the rock succession, whatever be the input method, we can define these packages in different orders, keeping in our mind that what is the aim, what is the objective of our work and how much of the packages are preserved which features are more easily identifiable, more easily traceable laterally, more easily correlatable across the basin, and depending on that we can define or use different models which are available. So, we can define a genetic sequence, we can define a TR sequence, or we can define a depositional sequence. So, these are some references for your further study. So, thank you everyone.